All right, so now we have that. And that's just the example here just shows you what it means by going up there. So for example, find the probability of getting a diamond and a 2 without replacements. So event A is getting a diamond, event B is getting a 2. So first off is getting a diamond, so it's 13 out of 52. And now notice this is the new stuff, right? That's the conditional part. So this is probably getting a 2, so there's 4 2s out of now 51 cards, because it's without replacements. So again, all we're doing is defining this in mathematical, because we need to define it, what it means in the word itself. Okay, that's it. All right, so let's try these out. So let's do more examples. So example 2 says, suppose a student needed to answer 2 questions, the first being a true and false question, and the other being a multiple choice question, with A, B, and C, D being the choices. If the answer to the first question was true and the answer to the second question was B, find the probability where the student gets both questions correct. All right, both, right? Both is and. So my event A is true, and my event B is multiple choice, right? Getting multiple choice correct. So since it's both, it's the addition. It's the and rule, so it's multiplication. So what's the probability of getting a true and false question correct? 1 out of 2, correct? Right, 1 out of 2 times multiple choice. So how many choices? There's only one way to get B. Out of how many choices do we have? 1, 2, 3, 4. Out of 4. So answer is 1 out of 8. I believe 0.16, I believe. Or sorry, 0.25. 125. There we go. So these were independent events because one did not affect the other one. Okay. All right, so let's keep going. So again, mine got a little cut off here when it came to it. So I'll do this. All right. Question 3 says, goes back to our little polygraph test. So suppose 2 subjects are randomly selected without replacements. All right, so we told us, right, without replacements. Find the probability that the first subject gets a positive test and the second subject gets a negative test. So A is positive test, B is negative test. It is and, so which means we're doing multiplication, right? All right, so let's see. What is the probability of someone getting a positive test? So positive test is all of these people, right? So that was earlier, right? 57. So 57 over 98 times how many people got a negative test? Well, that's over here. That's a total of 41. So 41. Now, again, right, without replacements. So if I took a person out, therefore, how many people are left over? 47. Right? And there we go. And lastly, all we do is just multiply them. Multiply them and divide, and we get our answer itself. Okay. Hopefully not too bad when it comes to it. Okay. All right, so now let's go to question 4. So question 4 says, find the probability that the first card you pick up is a 4, and the second card is also a 4. So you want 2 4s in a row. Okay. All right, so let's do that. Here are the conditions though. The 2 cards selected are selected with replacements. So the first card is put back in. So when it comes to, okay. So let's see what we get. So it's the and, right? We want both cards, so and, so it's multiplication. So there are 4 4s in the deck out of 52. And since it says with replacements, I'm putting it back in the deck, and we get that. Okay. And then B, same scenario. However, now it says with replacements. So hopefully you guys get the hang of this, right? So 4 out of 52. But this time it'll be 3 out of 51 now, right? Because there's one less card at 4s, and there's one total cards gone as well when it comes to it. Okay. That's to there when it comes to it. So we're going to skip question 5 there. This is a question I like doing in class anyways when it comes to it. It's easier to explain in class, which we're not going to do in class anyways, so we're just going to skip that. All right, so question 6 kind of cut off. So I'm just going to go to the back when it comes to it. You guys can read it as well. So the most important thing is we have a total of 810 scales, and it says 102 scales are defective, right? That's the main focus of this question. So A says, if 3 of the 810 scales are randomly selected without replacements, so I want 3 of them, find the probability that they are defective. They. So they is abbreviation for and. So I want 3 of them. So I should have, just like the deck of cards, the first one, second one, and the third one, right? I want 3 probabilities together because I want ands. So what is the probability of the first one being defective? I want you guys to try this one out. So go ahead and give a quick pause, 3, 2, 1, pause, try it out, and see what you guys get. Okay. All right, so what's the probability of 1 being defective? Well, there's 102 total, so 102 out of 810, right, are defective. Well, if I took 1 out, therefore there's 101 left over out of 809. And then there's now 100 left out of 808, right? So notice it deducted 1 every single time, just like the cards, right? I'm just taking 1 out every single time, so therefore everything gets deducted. So then once you multiply this out, you get 0.002-ish, I believe, when it comes to it. So speaking about this, so now I want you guys to try B, very similar to part A. If 4 of the scales are randomly selected without replacements again, find the probability they are not defective. So give it a quick pause and let's try this one out. So 3, 2, 1, pause. Okay, so hopefully you guys got it. Let's do this together now when it comes to it. All right, so there we go. Not defective. So if 102 scales are defective, how many are not defective? Well, you subtract them, right? So 708 are working or not defective, right? And since we want 4 not defective, well, there's 7 or 8 out of 810 for the first one. The second one, or the third one, and finally for the fourth one. And there you go. So this gives you approximately, I believe, if I did this correctly, 5, 8, 3. Right, so just be wary when it comes to right. So one of the major things that a lot of people do, especially for these questions, is they put 1 over 810. And again, that goes back to you not understanding what basic probability is, right? So I told you guys, right, the first section of probability is very simple. It's just defining stuff. And a lot of stuff is you're not defining is, well, what is it? How many ways can you get a defective scale? Well, there's 102 total ways you can get it, not just one, right? You're picking one out of that. There's a big difference when it comes to it, just like the cards, right, when it comes to it. So just be wary of that concept itself. Okay? All right, so now that we have that concept here, we're going to talk about more about this given probability, which is a little bit more difficult to deal with, okay? And that's going to be the next video.